Welcome everyone to the part 12 of our project. Today we're gonna make something, I'm sure you've guessed it, a little bit more complex than last time, and it's gonna be a glass material. I've set up my scene almost as before. Just for demonstration purposes, I've added a sphere and a cube to my scene. This will look as if it is a glass window. Okay. And without further ado, let's start. To create a glass material, there is a really simple way to do that with the principal BSDF shader. First, set the transmission value to 1 and then reduce the roughness to 0. And that's it. That's the end of the lesson. You've got your glass material. But no, I mean, you could stop here, but I like to customize a little bit my glass shader, and so for that I'm gonna show you a few more things. First of all, my setup here is a bit different than usual, because in order to see exactly or a bit better the results, I'm in rendered shading mode, okay, and then clicking on the little arrow on its right, I have unchecked scene world. If you keep it checked, by default the scene world is a uniform gray color, so that would be the result we get. So in order to not have this like that, and to simplify the process, I have unchecked this so that I can get the same kind of environment that we usually get using the material preview shading mode. Okay? And now, for the material part, you have to understand that if you look at all the shaders in the shader category here, a lot of them were what we used before we had the principal BSDF, and the principal BSDF is a combination of all of them, so that you can get all the results with just one node, which is much more simpler in most of the cases. But what we want to do today is to rebuild a shader from almost scratch. So we're gonna remove this and create by hand, let's say by hand, 4 parts of what a glass shader does. First one is what is called refraction, meaning that a light ray that goes through a glass object is slightly deviated. So for that I'm gonna add in the shader category, I'm gonna add a refraction BSDF. So this will make all the light rays going through the glass object deviate from its original direction, okay, and what controls that is called IOR, or index of refraction, and is set for glass to 1.45, which is a good value. If it is set to 1, all the rays go straight and aren't deviated. So we're gonna set this to 145 again. Okay. The second thing happening in glass is reflection, meaning that the environment is also reflected on the object. So I'm gonna add another node and use a glossy BSDF. This what controls something like reflections. Look how this looks like. It could be metal. And to mix both, I'm gonna use what we used before on my keyboard, the shortcut hold Ctrl and Shift key and drag with your right mouse button a line between the two nodes, and this will add not a mix RGB as we had before, but a mix shader to mix two shaders together. To control which shader we see and where, I'm gonna use something that we called Fresnel. There is a node that has its name in the input category, and if you look at this node, it differentiates the areas of the object facing the viewer from the areas that are not facing the viewer. This is exactly what we want. We want to use this kind of mix factor between our two shaders so that the reflections, and be careful, remember to turn down the roughness to 0 as we did before on our principal BSDF, and now the reflections are visible on the parts of the object that are not facing us, while when it is facing us, it is using mostly the refraction. I like to add a color ramp after the Fresnel to control a bit more the effect, make the white whiter and more present all through the objects, but the center darker. Something like that. And maybe this could be a bit darker as well. Okay? That is strictly a test setting, so you can adjust this just the way you want, or even don't use a color ramp. Okay, so I have the beginning of my glass shader. You can see it's almost looking like what we had before. And so now what I'm gonna add, the third aspect of it, is called dispersion. Dispersion is like having the three components of the white light, meaning R, G, and B, red, green, and blue, separated and slightly offset one from the other. So to do that, I can simply have three copies of my reflection shader, all set to a specific color, so red for the first one, green for the second one, and then blue for the third one. Like that, and I can combine them all together using a node that you can find in the shader group called Add Shader. I will add those three shaders together. I can duplicate it here and add then the blue. This way, at the moment, we've got exactly what we had before, because the combination of all these three colors makes a white color, so nothing has changed. But remember, I said that this value determines the angle of deviation of the light ray. If I modify this one, let's say this small number, and I modify blue one as well with the same number but subtract it to the original number. If you look close to your object, you see that on the edges we got some kind of color or light dispersion, meaning we can see red, green and blue tint in the places of our glass. Okay, this is dispersion. And now the fourth one, you might have heard of it, is called Caustics. And Caustics happens in the shadows of a glass object and is about the light, because the light is spread and dispersed inside of the object. The shadows area got some kind of light patterns that are sometimes interesting. To do that, I'm gonna add another shader, and this time it's a transparent shader. I'm gonna mix it with what we already have here, like that. You can see it has already an effect on the glass, but that's not what we want. We want to only affect the shadowed area. So for that, as an input to this mix shader, we're gonna use a new node and found in the input category. It is called light path. This is used to determine the nature of the light ray. If we use is shadow ray as a factor for our mix shader, this means that it will only affect all the rays that are considered a shadow, meaning we are only gonna affect the shadow area of our object. The transparent BSDF has only a color input, but we can cheat a little bit here. If we add a value node and plug it to the color input, you can see with a value of 0, remember, it's equivalent to having a black color. We have what we had at the beginning. So now I can modify this and see how this is affecting the shadowed areas of our object. At the moment it's far too much, because it's just like we have light bleeding everywhere. So I'm gonna set it to something close to 1. Okay, and I'm gonna mix that to have something a bit more interesting with a texture. I'm gonna use a noise texture and mix both together with a mix RGB node this time. I'm gonna set that to multiply and use an output we haven't used before, is the color output from the noise texture. Okay, meaning that we will color a bit this shadowed area. You can see it's slightly visible here, but I'm gonna change the factor here so that we can see it better. See now, there are colors in the shadows. I can modify this a little bit. Okay, but we can see a bit more, and maybe increase this as well, just slightly. Okay, and now we've got our glass shader, which is close to what we had before, but it is now a bit more interesting because we have something that really happens in the real world, meaning the Fresnel effect, to differentiate the refraction and the reflection. We've got light dispersion that makes a glass object a bit more interesting, and we also got caustics that are a bit more interesting as well. The following part is not necessary, but it helps to modify a few settings if you want later on to customize your glass shader, and this is regarding this area. So at the moment, you remember, I have set a manual offset value in the red IOR and the blue IOR, and what I want is to have something that I can modify but much more easier. So I'm gonna use two value nodes, one set to 145, which will be our default IOR value, and one set to 0.007, which was the value we used as an offset. And what we can do to combine those values is use a math node. Okay, by default it is set to add, so meaning that if we enter this value and this value, the output is what we use here for the red. So let's plug that to the red. Okay, this value 1.45 is the one used in the green, so we can plug this directly here. And here we subtracted this value to the original one, so let's duplicate this math node and set its settings from add to subtract, and then connect both those values here and set it as an IOR value for our blue refraction node, meaning that at the moment we've got exactly the same result because it's the same value, but I could make it different. Okay, if it's too much, then you can see too much, but have a look at that. Our glass is a lot colored, but that could be an artistic choice to have a value as high as this. I'm going to set it to the previous value, so that's done. And the last thing I would like to add to these settings is, at the moment we've got white glass, so that's okay. But what if I want to have a tinted glass? These colors, okay, added together makes white. But if I want, let's say, something more purple, I will have to know that I need to reduce the amount of green to have something more purple. And of course, if I want a more complex color, maybe it will be more difficult for me to find it. What I can do is reverse the process, meaning we are combining this to get something white. But what if we start from a white color, or for the color that we want to have at the end? So let's start with the RGB node, okay? And there are nodes that allow us to separate and also combine values afterwards. What we want here is to separate the RGB, okay? So let's add this here, plug the color to the input, and now we've got a red output, a green output, and a blue output. This, if you remember from our earlier lessons, are just a one value outputs, okay? And what we need here is a color output which is 3 values. So we can't use it directly here, okay? Because otherwise we will have outputs, something going from 0 to 1, so a black and white value. So we need now to add a color mix RGB node and to multiply the input value like that by our color. I can simply left click and drag this color here like that, and the output of this, if I set the factor to 1, is red, okay? So that's exactly what we want, and now we can do it for all the other colors. I'm gonna set it to that, duplicate this of the green output, set the green color here, and duplicate this again. I'm not moving it here so that because I don't want it to be included inside this connection. Okay, so at the moment it's a bit messy, but let's do it like that. Oops. And so we got our red, our green, and our blue. if I have a look at the resulting color, this is what we've got. I think I haven't made any mistake. Let's put that like this. Okay, it's not, because now it's not totally white. So we got the same results as before, but now if I, let's say, want the purple color, I can set it directly here, and these settings allows me to separate the components of this color into these three colors that will be then fed to the reflection shaders. And now we can have a tinted glass, and also, as I said earlier, control over the dispersion. So that's it. We've got our complete glass shader, but that wasn't a joke, and I just forgot something. Of course, there are parameters that we've all set to 0 before. It's the roughness values, but we can use it to have, like, at 0 totally clear glass, but if we set that to any other value, we can have something like frosted glass. So to do that, we can simply have a value node. Let's set this to 0 at the moment, and this can drive all the roughness values. I'm gonna plug this here, and there is another roughness somewhere, which is the one from the glossy shader here. Okay, now this should be okay. Let's modify that a bit and see how we get frosted glass. Okay, it is definitely done. Now from this, you shouldn't have anything to add to your glass shader. Hope that wasn't too complicated. I have the feeling it gets less and less complicated each time we create a new shader. Hope this feeling is shared. I wish you a lot of success with all your shaders, and I'll see you in the next part. Take care, everyone.